Morning, everyone. So this video is welcome to my YouTube channel. This video is meant to be an introduction before we get into the meat and potatoes of Wednesday's lecture. The first part of class is going to be functions of specific muscles, major muscles of the body and what they do. Now, before we get into that, I want to talk about some semantics. What do they do? The term do. That infers action, a doer, someone of action. And action infers movement. So and I say infers, right? We don't assume, but we can infer. So think about Newton's third law, action, reaction. And what that makes you think is that when something moves, something else must move. Action, reaction. But the reality is it may not move. It may move, but it may not. You have action, reaction taking place anywhere you have two forces from two different objects applying to each other. So what I mean by that is, let's say I have my phone on my hand and I don't have any observable motion, some little bits, but nothing. Okay. So someone might say, well, the only way to have action reaction is if I have action, if it's doing something. And the physicist says, well, no, there's action reaction, because action reaction is really force counter force. It's not necessarily that there's going to be motion. There may be motion, but there doesn't have to be motion. But what's really happening is these two objects, the cell phone and my hand, are trying to move each other. Trying. That's an action, to try to do something. A team, when they play a game, tries to win, but that doesn't mean they always win. Does that make sense? The action is in the try. The action is my hand is trying to make the cell phone go up. Why? Because the hand is pushing in the upwards direction on the cell phone. But the reason the cell phone isn't going up is because my hand is only pushing up with as much force as planet Earth is pulling down. Those forces are balanced. The scale is balanced. If my hand were to push with more force than planet Earth is pulling down, well, then I would accelerate the cell phone upward. So the key thing here is the try. Action in physics isn't necessarily movement, it's to try. And the same thing goes with muscles and their function. Same thing. It really is the same analogy. A lot of times people will refer to muscles and their functions as muscle action. You see where I'm going with this? The action of the muscle. And that infers movement. And a lot of times we may have movement, but sometimes we may not have movement. Think about isometric contractions, right? In isometrics, which therapists do a lot of isometrics, we do a lot of isometrics. Just me keeping my head up. It's because of isometric work of my cervical extensors. So muscles have action in the absence of motion through isometrics. So action is not a very clean word because it infers movement. So the term we use for what does a muscle do is, well, what is a muscle trying to do? Force, counterforce. What direction of motion is that muscle supplying its force in? Whether it moves or not, it's trying. And so that's how we look at muscles and their function. What direction of motion is the muscle trying to cause? It may cause motion in that direction of pull. It may not. It may be preventing motion. Just like if I had a dumbbell in my hand and my elbow flexors would be preventing extension, right? That's a function. That's a job. Take away function and put in job. What's the job of that muscle? The job of the heart muscle, the job of the diaphragm, the job of the tongue. What's the job of the bicep? What is it trying to do? Okay? So that's what the first part of this class is all about. Function, the jobs of specific muscles. And if we review what we did in 310, where I taught you how muscles work based on their direction of pull, right? So we have as many groups of muscles as we have allowable joint motions. What can the wrist do? The wrist can flex and extend in its sagittal plane. Hey, we need a group of muscles that pull in the direction of flexion, and we need strings, muscles that pull in the direction of extension. And what are we going to call them? Well, the flexion pullers are going to be called flexors, and the extension pullers are going to be called extensors. Are the flexion pullers always going to produce flexion? Sometimes the flexion pullers prevent extension. If they didn't work, right? And sometimes the flexion pullers allow extension through eccentric work. Remember that? So the same concept. Flexion pullers or flexors, not that the action that they do is flexion. Because sometimes those flexion pullers can do extension through eccentric work, and sometimes those flexion pullers can be responsible for no motion through isometric work. So the action isn't flexion. The action is flexion pulling. It's pulling in the direction of flexion. It's trying to flex. So even when the flexion pullers cause flexion through concentric work, prevent extension through eccentrics, prevent extension through isometrics, allow extension through eccentrics, the direction of pull is the same, therefore the function is the same. Its function is its direction of pull. That is the most important thing from this lecture. When I say function, I'm talking about the direction of pull that a muscle has. And the direction of pull a muscle has is irrelevant whether it's working or not. Your muscles pull when they're at rest. Your muscles pull when you are dead. Your muscles are always pulling in directions of motion. So that's what we're talking about with function. The biceps brachii is an elbow flexor, not because it flexes the elbow. I can have my tricep be responsible for flexing my elbow. Biceps brachii is a flexion puller. It's an elbow flexion puller, meaning that it pulls in the direction of elbow flexion. And sometimes it's responsible for the action of flexion, but sometimes it's responsible for the action of extension, and sometimes it's responsible for the action of preventing extension, no motion. But in all three cases, flexion, extension, and isometric, flexion, extension, and isometric no motion, it's still pulling the same way. It's pulling in the direction of elbow flexion. So some of you, especially my athletic training students, this might be some different verbiage than what you're used to. That's okay. Different is okay, as long as it's explained why. I am an athletic trainer, certified athletic trainer. Passed my test back when it was old school, like written, took us hours and hours. Crazy. No regrets, man. I learned a lot in my athletic training career. But verbiage could be better. This is the biomechanist speaking to the athletic trainer, me, in this video. Like if I'm watching it as an athletic trainer in the 90s, you might have textbooks that say the biceps brachii function or the biceps brachii action, and then they'll say elbow flexion. They'll give a motion. They'll give an action to the action. Biceps brachii, elbow flexion. And I just proved to you that the biceps brachii can be responsible for elbow extension through eccentric work. My tricep could be responsible for elbow flexion through eccentric work. The biceps brachii could be working and we have no motion through isometric work. So how do you remedy all these issues? Simple. You realize that the action of the muscle isn't necessarily linked to a motion. You remember in 310? We do not associate muscles with motion. We do not associate muscles with motion. We do not associate muscles with motion. Why? Because of eccentrics and isometrics. Think about it. If we said the biceps brachii action function is elbow flexion, and I just proved that of the 3 types of muscle contractions, isometric and eccentric, only 1/3 of the time will the biceps brachii actually do elbow flexion. 2/3 of the time, that will not make sense. 2/3 of the time, you're either going to have motion in the opposite direction of pull, or you're going to have no motion because of the direction of pull. So how do we remedy this paradox? By simply adding the word puller and the concept of direction of pull. So if you have a textbook that says biceps brachii, elbow flexion, simply add in, whether it's inside here or on your book, biceps brachii, elbow flexion puller. A flexion puller, meaning that it pulls in that direction, but it's not necessarily going to always cause motion in that direction. That is extremely important. The triceps brachii, an elbow extension puller, meaning that it will not always be responsible for elbow extension, but it will always pull that way. And when it pulls that way, it's going to be responsible for extension when it's working concentrically, and only when it's working concentrically. But it could also be responsible for flexion when it's working eccentrically. And isometrically, it's going to be preventing flexion. It's 310 stuff. So we got to touch up on our 310 concepts of muscle contraction, muscle work. Okay? So that's important. Direction of pull. And that's what flexor means. So biceps brachii, elbow flexion puller. Well, what's another word to say elbow flexion puller, elbow flexor? Elbow flexor means elbow flexion puller. Pulls in the direction of elbow flexion. Elbow flexion puller. Flexor. Shorter, but it means the same thing. It's like a contraction. Contraction. Elbow flexion puller. Flexor. Elbow extension puller. Elbow extensor. Get it? Hip flexion puller. Hip flexor. Hip extension puller. Hip extensor. So that is the first thing we need to do, is really tie in the verbiage and not fall for a term like action and think there has to be motion. Function. That's why I like to use the word function. What does it do? And when I say what does it do, what direction of motion does it pull? Because the direction of pull is the only thing that's consistent. That biceps brachii pulls in the direction of elbow flexion, whether it's concentric, eccentric, isometric, alive, dead, doesn't matter, pulls that way. The only way to get it to not pull that way is to, or if you ruptured it, that's a bad day. But if you ruptured it, then it can no longer pull in that direction. But if it's attached and it always has pull force, it always has tone, it's pulling in the direction of elbow flexion. Okay? So we got to get that concept down. Some of the things you guys can do to practice or to sharpen your, think of it as training camp, right? In other words, the season starts Wednesday. That's when I'm going to get my first lecture on muscles of the cervical, main muscles here. You're going to have cervical flexors, cervical extensors, right lateral, right transverse, left transverse. What you guys can do to sharpen your skills for that lecture is do 310 review. 310 review, where you go through your book, you look at examples of muscle groups. So remember, no skeletal muscle works by itself in terms of influencing joint motion. You have multiple joints that pull, multiple muscles that pull in every direction of joint motion. So we group them based on their direction of pull. Wrist flexors, wrist extensors, wrist ulna deviators, wrist radial deviators, right lateral cervical benders, left lateral cervical benders, right transverse cervical rotators, left transverse cervical rotators. Now you know, well, hinted to you that right transverse cervical rotators we don't associate muscles with motion. It doesn't necessarily mean every time you see that motion it's because of those muscles. It means that these muscles pull this way no matter what. And sometimes you need them to make you move that way, or to resist you going the other way, or to prevent you from going the other way. But in all three cases, they still try. They still pull that way. So the analogy, remember in 310, I said it's, with the tug of war analogy, meaning that when you're playing tug of war, you pull in the same direction win, lose, or draw. When you're winning, the motion is in the direction of pull. But when you're losing, the motion is in the opposite direction of your pull. You're still pulling the same way. And when you're tying, there is no motion, but you still have the same direction of pull. That's a 310 review, but it's an important review. That when you're playing tug of war, you're trying to shorten the rope. Whether it is or not, whether it's moving away from your pull, with your pull, or there's no motion with your pull, that is what contraction is. The type of motion or lack of motion while you're trying to move it. Okay? So your homework is, for the rest of class, a 20-minute short lecture. I want to plant some seeds, do some exercises around the house or in the gym, safety first, and review things like external force is trying to adduct me. I need to recruit abductors isometrically to maintain this position, concentrically to abduct me in the presence of something trying to adduct me, and eccentrically to adduct me in the same direction that something's trying to adduct me slower than gravity. Practice those. External force is trying to do what? By understanding external forces, that's how we can understand internal forces. To know which muscles we need to call, we have to first ask ourselves, why do we need to call them? When you get out your Rolodex to call someone, there's a reason that you're making that call. There's always a reason. It's no different in the body. Bicep, get up and do a job greater than resting tone. Why? We have to understand the why. Well, because something's trying to extend me right now, and I need you to prevent that from happening. Oh, okay. Call, zap, innervate, contract above resting tone, doing a job. Okay, bicep, make it flex. Make my elbow flex greater than external force. All right. Okay, bicep, stop. Okay, now bicep, let me extend. Okay, well, I need to let off a little bit. Okay, bicep, we're good. Slow us down. I need to pull with more. Plyometric sequence, right? Slowing it down through eccentric, speeding up through concentric. We've got to practice all that stuff. Biomechanics is, we're going to take those 310 concepts, contractions, motion, the equation that I taught you guys, and then we're going to apply it to individual muscles. I'm going to show you individual muscles, and I'm going to show you how, this is really cool, how a right sternocleidomastoid actually pulls in the direction of left transverse cervical rotation. Right lateral bender, but a left transverse cervical rotator. And the only way I can teach you that is to show you the mechanics of how these muscles cross those different joints in our body and say, hey, look, in the frontal plane, look how it's trying to pull your right ear to your right shoulder. You see how it would want to pull this way? And in the transverse plane, look at how it's trying to pull your ear. It's a little bone next to your ear, but it's trying to pull your ear forward. That would make you want to try to make you look to your left. Okay? So that's all of what function is. Direction of pull. What is it trying to do? Okay? All right. I'm going to post this video, and I'm also going to post all of the supplemental materials you guys need for this class. Basically, it's your workbook. Print it out. Just store it on your computer. I don't care. If you print it out, maybe you could use highlighters for the different muscles, and you can write notes on it. Whatever works for you, okay? All right, guys. Do some studying. Do some practice. Muscles in the groups, and then I'm going to teach you who those muscles are. All right? Let's do this.